Okay, so let's go over some cloud fundamentals. And we'll start in the early days of wide area networking when many companies didn't have any wide area networking. They weren't connected at all. They were completely separate and segregated from each other. And if they wanted to exchange information, they'd have to either mail each other disks or some sort of hard drive or tapes, or they would simply print things out and send paper copies, which was probably the most common. They were essentially operating in a bubble. Some companies, especially the bigger ones, were able to purchase private lease lines, and these were actual cables that were run by phone companies or other carriers between two offices. Now, these lines required special equipment on either end to connect the two networks together and to pass the traffic, and they were expensive, they were very slow, and often only certain types of traffic was transferred for those reasons. So, companies began using modems to make use of the PSTN, or the publicly switched telephone network, to transmit data. And this happened over regular phone lines, what was called plain old telephone service, or POTS lines. Now, unlike a lease line, these lines were not always active, so they were considered on-demand lines because the connection was only active when a call was placed. Now, as POTS lines started to go from analog to digital, carriers were able to combine multiple digital lines together to create larger bandwidth circuits, which they called ISDN, or Integrated Service Digital Network. And even with these larger bandwidth circuits, however, these were still on-demand links, or something that needed to be dialed to the other side. And they were also very costly. But they became very popular and are still popular in certain parts of the world. So carriers started to develop their own networking infrastructure that spanned different cities and regions, and they would offer companies the ability to connect their offices to a local point of presence on these networks. And this allowed the customers to send traffic between remote offices by hopping across the carrier's interconnected equipment on that network. Now, the most common type of data transfer over these types of connections was called X.25, and later on frame relay. Now, X.25 was designed to transmit data over the carrier's network, whereas frame relay was actually designed to send data over more public networks like ISDN. Although both of these protocols, X.25 and frame relay, could both be used over lease lines or public networks or private networks, whatever the connection was. Frame relay in particular was a big milestone in the history of the cloud, because it was during the 90s that the phrase virtual private connection and cloud started to be thrown around a lot to describe what was happening. In this case, two separate networks believed that they had a private connection between them, like over a leased line, when in fact the data was being transmitted over the carrier's public or semi-public infrastructure, or cloud. Nowadays, the idea of using a carrier's private network that is separate from or adjacent to a public network like the internet still exists in the form of circuits like MPLS, which you may have heard of. And MPLS is actually still a very much preferred method of inter-office network connectivity, because public networks can result in a significant amount of lag or latency due to the design and the security requirements of VPN connections that have to be put in place to communicate over them. And we'll get into that on the next slide. Okay, so with the arrival of the internet, wide area networking was given new life. Now, many companies were connected to a public network in an always-on fashion and with high-speed connections. And this was great for connectivity, but this was not so good for security. Also, the internet standardized on using TCP/IP as its networking protocol, and it was determined that certain types of data and certain network addresses were not to be transmitted over the public internet. Now, this was for security reasons, as well as to cut down a lot on the traffic that TCP/IP generated under normal circumstances, and also because there weren't enough addresses to give every single device an address on the public network. So there were some addresses that were only meant for internal use and could be reused by multiple companies. They would never actually make it onto the public network or the internet. So in order to transmit private data between two corporate networks over a public network such as the internet, there needed to be a way to encapsulate or bury that traffic inside another type of traffic that could be transmitted over the internet, and also to add encryption to it. And this became the basis of VPNs, or virtual private networks. They took the idea of VPCs, or virtual private connections, from frame relay and combined it with encryption to create VPNs. Now, two computers from two different offices could communicate as if they were sitting on the same network or in the same building, but the traffic would be encrypted, encapsulated, sent over the internet to the other office where it was then decrypted, and the encapsulation payload could be forwarded on to the remote network or the remote computer. And this was done in an always-on fashion. The VPN connection was called a site-to-site VPN because it was set up between the two offices to be always on and always active. All you had to do was address a computer on the other side, and all that encryption, encapsulation, and decryption and decapsulation would automatically happen. So now companies that were geographically dispersed could communicate with each other in a secure and high-speed way over great distances using the internet. And this ushered in a new type of network design where resources can be accessed in remote locations. So not every office required all the necessary IT infrastructure to provide its local users with local copies of the resources it needed. Certain resources can now be centrally located, and the proper amount of hardware could be dedicated to achieve the best performance for that workload. So, for example, a company could maintain its database on optimized equipment in one central location, while its other locations had only users that could still access the database without the need of having local copies of that database in each of their offices. And with the internet also came the notion of websites. And while early on many companies decided to host their own website on-premise, companies quickly learned that it was only complicating things by adding security concerns and overall stress to their infrastructure due to all the network traffic that was hitting it. So nowadays, most companies outsource their web hosting to dedicated hosting providers. And this is just another example of putting the right workload in the right location while being able to maintain access to it from anywhere, all thanks to secure connections over public networks. In the case of a website, users can access the website publicly at any time, and the company can also access the website through secure methods to make changes and manage it. Then companies started to realize that if they could put their workloads anywhere and still be connected, then they could put them in facilities that were less expensive to maintain and easily expandable without having to design their local facilities to prevent interruptions in service or spend a lot of money on construction costs. So they began to move equipment into managed facilities where they just rented rack space in a shared data center. There were no actual employees on sites. These facilities offered power, cooling, and security all for a low monthly cost, and most of them had high-speed connections to major carriers as well. So although the customers still had to pay for their usage, these lines, which could be internet lines or private lines or MPLS lines, generally had the potential for much higher speeds than a data center normally would if it was kept in an office building. These managed facilities were also designed to be more disaster resistant and offered better power and cooling than most businesses could put in their office buildings. It also freed companies to relocate or grow their office space easily without concern for their data center requirements. They only needed to worry about the spaces that would be used by the people. These managed facilities are referred to as colos because they are data centers where different businesses have their equipment co-located with each other. Now, many companies began using these colos as a secondary or disaster recovery site, but after a few outages in their primary location, they realized that the colo was actually better suited for the task, and the roles quickly shifted, where now the companies are using colos for their production environment and using the on-premise infrastructure as the DR. Once companies realized the advantages of moving production workloads off-premise, they began to look at other type of hosted services models. Instead of simply renting facilities, what if they rented the hardware too, such as the servers or the networking or the storage devices? They wouldn't have to purchase or build or maintain the hardware, and they could expand or scale their operations easily and with a predictable cost by renting more whenever it was necessary. There was also the idea that they could rent the software as well, either the platform used to create the applications they needed or the applications themselves. It's the application, after all, that the business wants. The infrastructure and the platform is just there to support the application. So by paying a rental fee or subscription for these technologies, companies are no longer buying tangible products, they're subscribing to services. So what's the difference between the two? Well, when you buy a product, you own it. It becomes your property. You have the right to do with it what you like, as long as it's legal. There are some software products that come with end-user license agreements or EULAs, but generally speaking, if the product doesn't interfere with anybody or anything, and it's not being used unlawfully, you can use it how you like. The exception being you need to buy enough copies to be compliant with the license policy. With a product, there's also a one-time cost associated with the purchase. Sometimes there's a recurring cost for maintenance support, but that's actually a service that's sold along with the product, and normally it's not mandatory. Also, and perhaps most importantly, with a product, it's the buyer who's ultimately responsible for the performance and function. Again, there may be support assistance sold with the product, but ultimately and continuously, the behavior and the performance of the product is up to the customer to maintain. Now, when you purchase a service, the customer does not own the product, and you must abide by the restrictions and the limitations set forth by the service provider. You can't do whatever you want with it, and you don't have access to the whole thing usually. There's a subscription and a recurring cost involved with the service for as long as you need it, and it's the vendor or service provider who is responsible for the function and performance. So what are you ultimately buying with each of these? Well, with the product, you're purchasing a tool that you need to build something or to achieve a particular business outcome. With a service, however, you're buying the business outcome itself along with all the guarantees that the outcome will be achieved. Now, there are some services that charge by the hour, but when you purchase those services, the business outcome is the time invested by the vendor, which means that when you purchase a service, it's important to know what the outcome being purchased is. Is it just time, or is it something deliverable? And that is set forth in the service level agreement. The service level agreement is the document or portion of a document where the customer and the service provider define the deliverables agreed upon under the services contract. In the case of IT services, and in particular hosting services, the most important agreed upon deliverable, besides meeting performance specifications, is the uptime or availability of the service. If you are paying a vendor or service provider to host your website or to host your database or to host your application, the provider needs to define in the SLA how much uptime it expects over a given period of time, and in turn how much downtime it can sustain before it's in breach of the SLA. This is what we mean when we refer to availability, and it's often measured in what's called nines. So 2 nines represent 99% uptime, 3 nines represent 99.9% uptime, and so on. Now 99.9% may seem like a lot of uptime and availability, but it actually can result in 8 hours of downtime per year without breaking the SLA, which makes 3 nines unacceptable to many companies. 4 nines is considered standard for many hosting contracts, which is around an hour of downtime per year, but some companies require 5 nines or less, which is about 5 minutes per year.